In this section, we're going to be talking about how to validate incoming data. So whenever we take in data, it's really important that we clean it up to make sure that it's the data that we want, not just the data anything or anyone will give us. That's really important when it comes to ensuring the integrity of our application and, more importantly, the integrity of our data. Speaking of integrity, we also need to make sure that we're testing these things automatically using the actual testing tools that we can. Now, testing and data validation are concepts that you're going to always want to reinforce and learn more and more about. So we're really just scratching the surface of those things, but the general idea is we still need to get it done. So let's go ahead and do that now. Since we have two database servers, one for our production server and one for our development server, and we have a way to connect to both of them through environment variables, it's time to actually make sure that the data that we end up using from and to that database is valid. It's actually really good data. So what we're going to start with is actually validating data and ensuring it fits a certain schema. And so to do this, we're going to be using a tool called Pydantic. So if we do pip freeze in here, we see this tool is already installed. This library is already installed. It's called Pydantic. And this is the first step we'll use prior to integrating into SQL Alchemy. Now, there is other ways to accomplish what it is that we're trying to do here. It's just that Pydantic is a very popular way to do it and also a very mature way to do it. So we're going to jump into the app here and we'll just go ahead and create a module called schema.py. And this is where we're going to design our schema, the things that we're going to end up storing into our database. So I'm going to start it off with just a simple class. In this class, we're going to just call it the entry schema. And I'm not going to have it inherit anything just yet. I just want to think about the data I'm trying to store. Now, of course, you can have all kinds of data in here, but I'm only going to have a couple. And the reason we're using Python classes, well, is several reasons. One of them being that Python classes are really good about holding state of data. So if you initialize or instantiate multiple versions of that class, you can have different kinds of data. Hopefully you already know that at this point, but the general idea here is I'm just making something called entry schema, and it's going to have a title and some content. I'm just giving it some arbitrary entry in here. And with this, what we want to do is we want to declare the actual data type it's going to be. So to declare a data type is just like this, right? So both of these are strings. Of course, if we wanted to have something else in here like ID, we could put in that ID as an integer. So 1, 2, 3, 4, 5, and so on. Now we'll definitely come back to ID, but for now, I just want these two things in here. Okay, so the goal of what we're building towards is to really just make sure that any sort of dictionary that we pass in will go through this schema, make sure it has the correct values, and then come back, and then we'll enter it into the database. Okay, so at this point, we have two fields, two different fields that will be end up saving in the database. Okay, so what is it that we want to do on these fields? Well, first of all, I definitely want to have a title, and perhaps I only maybe want to have a content field in here. So to actually bring in the content field, what I can do is I can import from typing, we can import the optional class here. So this optional class will allow me to actually use the string being optional and also setting a default, which I'm going to set as none. You could set it in as an empty string, but I'm going to leave it in as none. Okay, so now this entry schema is essentially title and maybe content. Okay, so to actually turn this into a actual schema that Pydantic manages, we're going to go ahead and import the class for it. So from Pydantic, we're going to import the base model. And I'm actually going to change this and save it as the base model schema. Okay. Now, the reason I change it is going to be more clear once we integrate the database stuff with the SQL Alchemy. But for now, I'll leave it in as the base model schema. And overall, this is just fine. We don't actually have to do a whole lot more to this. So let's actually take a look in the shell. So I'm going to jump into the shell and do from schema, import the entry schema. No, not the base model schema. Oops. Copy the entry schema. Press up here. There we go. And I'll go ahead and say my data is title and hello world. And then my content is going to be something. And then I'll also give some other data. ABC is 1, 2, 3. Okay. So now if I actually bring in that data, unpack it as keyword arguments and hit enter, this is what I get back. And then if I hit dict the dictionary, this is what comes back. So the original data is stripped out, right? So some of it is. Not all of it, but some of it, right? Now, if I try that same thing with just data and content and ABC, let's go ahead and get rid of title and run it again. Now I get a value error, a field required. Okay, so this is doing that validation for us to ensure any sort of data type, right, is coming through. So this also means that once we actually convert this or create a method to which our end users can use, like a post method, don't worry, we'll integrate this, and something like entry, right? This then would have to go, that data, whatever is being sent, will have to go through the schema and it'll have to be valid prior to actually saving it into the database. That's the key thing here. Now, there's a couple other things that we might want to consider with this schema, like the length of this title. So there's a couple of ways on how we could do it. There is a way to use a constant string here instead of a string, a regular string. But I'm going to do it in a way that I think is fairly intuitive and also something very similar to if you've used the Django REST framework ever. And so what we do here is we import the validator decorator from Pydantic, and then we declare a method like title length that's going to take in the class CLS and value, and then all other keyword args. Okay, so this value is going to be what's entered in here, right? So what we did before was hello world. It's essentially going to be whatever that value is. And so we can say if the length of that value is greater than 100, then we'll raise a value error and just basically say value cannot exceed 100 or whatever it might be. Otherwise, then we'll go ahead and return that value. Now, the reason I brought in this decorator here is because we want to decorate this method with validator and declare which field that we are validating against. So let me just go ahead and put this in as like 10 or even like 2, just to make sure that it is working correctly. So let's exit out of the shell here, bring it back in, press up a few times, and also again with the data, and then the final one of the actual schema itself. And there we go. So now we have a different kind of value error. First, it was required, which is what happens when you don't put a default value and you don't use optional. And then now it also has this other validator, which I think is cool. Okay, cool. So that is our baseline schema that we'll end up using. Now, the thing is, this schema is not all we want, right? So this is going to be when we actually create stuff. So really, if you think about this, this is the entry create schema. The next one would be the entry list schema. So class entry list schema. So that is if we want all of this data to be coming out, what is it going to look like? Well, it's going to go ahead and inherit from the original schema itself. That way it includes these fields. And if we accidentally use the create method for this one, we would still have that same validator. And then now I'm going to go ahead and put the ID in here. And I'm also going to put in a couple other fields that we still have yet to implement, one being timestamp and one being updated. So these are going to be date time types. So we're going to go ahead and import date time here. And we're going to use datetime.datetime. So datetime.datetime. That is what the type is going to be. And let's see, let's copy this. There we go. So that's the optional value, or at least that should be an optional value. And the default will just be UTC now. This is just going to get the UTC now timestamp for these fields if they're not already set. So I'll come in here and make these optional as well, just like we did with the content value. Okay, so in the long run, I'm going to have the database actually setting these fields. So before I go any further, let's talk about the different fields that I will have in the database. And that is going to be the ID field, the title field, content, timestamp, and updated. So those are the fields that we want to store in the database table for simply entry. And all of these are doing is just verifying and ensuring that this data works and is valid. So now that we have that, it is actually a good idea to run and make automated tests to ensure that all of this works instead of actually jumping into the shell every time to make sure it works, of course. The data validators check the integrity of the data we're going to store in the database. What tests will allow me to do is to check the integrity of these data validators or these Pydantic models. So to do this, we're going to go ahead and create a new file called test_schema.py. And what I want to do now is I want to install pip install pytest. And I'm going to go ahead and add in pytest to my requirements here. Okay. So test underscore is definitely how we want to name it. The next thing is I want to do pytest.ini, INI. And the reason for this is just to make sure that we're not actually testing our bin include and lib. So any of those libraries that came in because of our virtual environment, I'm going to go ahead and ignore those tests. You totally can, but I'm going to ignore them. So really, if I do pytest and then period, it shouldn't test anything yet, right? So no tests ran. And that's why I actually bring in that pyini. If I leave this out, save it, and then run, it's going to run a test related to the virtual environment, which is fine. It's just going to find errors and things that, perhaps we aren't going to try to attempt to solve at this point. Okay, cool. So now that we've got this, let's go ahead and write out our first test. So what we want to do is define a method here, and we're going to call it test underscore. So always, whenever you are writing out tests, especially with pytest, you're going to go ahead and use the test underscore. So that's also true for the module name itself. Okay, so in here, we're going to go ahead and test entry create schema valid. Okay, so what does this mean? Well, we want to get a data, and we'll go ahead and say title and something like hello world. Okay, so I'm really just testing to make sure that this schema right here works against this dictionary. So that means I have to import a couple things. So I'm going to go ahead and import schemas. We'll just start with schemas. And I'm going to go ahead and just do schemas dot, or rather this should be import schema. We called the module itself schema. So schema dot, and then the name of the class. Okay. So yes, you can absolutely import from schema, import the class this way, which is often a really good idea. But the reason I do this in tests is so that if I add additional schemas, I can just really quickly write up a test for it. And now we're going to go ahead and unpack this data. Okay, so as of now, this test should run. So let's go ahead and do pytest period. And sure enough, it does. One was passed. We only did one test. Now, if I change this to content, and this should be invalid schema now, I get a validation error. Okay, so let's go ahead and just do two of them now, because we actually just ran two tests. So entry schema invalid is going to be this content here. So I'm testing that it's valid and invalid based off of the actual data points that I brought in, the actual fields, if you will. And so how do I actually test if it's invalid? Well, now what I'm going to do is I'm going to import pytest, and from here, we're going to go ahead and do with pytest.raises validation error. Okay, so I want this validation error. And this validation error actually comes from Pydantic, which is actually right here. Okay, so in this case, I'll go ahead and do from pydantic.error wrappers. We're going to go ahead and import that validation error. Okay, so really I'm just testing to make sure that this one is invalid and it raises that validation error, which is the error we just saw. So now I run this again, and there we go. Now, we certainly can make this a better test. I'm not going to spend a lot of time making these tests amazing. I just want to spend some time making sure that they actually work so that we have at least some sort of way to automatically check that our schemas are done correctly. This next one is actually testing the validation. So test entry, create schema title, length or something like that. And then in here, what I could do is actually hard code out a length of some kind. Or what I could do is say the arbitrary title is equal to the string of something like this. So join and then x for x in range of, let's say, 105. Okay, so this is now our arbitrary title. What it should do is give me a long string of numbers, and again, a string, that's the key part there, that we're going to test against. So now this is going to be invalid, so let's go ahead and run it. And we get this running here. Oh yeah, we actually have to turn this into a string as well, so we use f-string substitution. Or actually, probably better to just do str. Right? Or we could, even better, we can just use a, and that will make a list, a bunch of lists of a, and then we'll try that again. And now we've got a cannot exceed value type. Okay, so yet another validation error. So we'll go ahead and say invalid yet again, and I'll pass in this validation error for that length. Okay, so there we go. And let's say max length equals to 100. Let's put it there. And then we'll do +1. Let's spell length correctly. Run that again. And now it passes. Okay, cool. So if I put this in as 99, let's try it again. Fails. Okay, cool. So back to 100. And let's do the validation. The valid correct one. Okay, and bring it back. And put that back at 100. And there we go. Okay, so again, if it's 101, it's going to be fail. Just by 1. Okay, so that's good. Next, of course, we could bring in another test, and we can say test create schema strips data. Okay, so in here, I'm going to go ahead and add another key in here of ABC and something like 1, 2, 3. And this time I'll go ahead and say obj is equal to that schema. And then I really just want to get the data from that. So obj dict equals to obj dot, dict, just like that. And then I want to get the keys. So I actually am going to change that from that to keys. And then we'll do dot keys. And now I want to assert that the length of obj keys is going to be equal to 2. Now, the reason it's going to be equal to 2 has to do with our schema here, right? There's 2 fields. So either way, those 2 fields are going to come back, even if there's not a value for them in this data right here, right? The next thing is I want to go ahead and assert that the set of obj keys is not equal to the set of data.keys, right? So in other words, this is being stripped out. Now, of course, I could also check that obj underscore keys does not have that value at all, which is okay. The next thing I want to assert is the obj.title is equal to the data title. Okay. So again, making sure that that data is coming through. So this might be another one that would be good for just a general test instead of down here. It doesn't necessarily have to happen in the stripping data part. So that would be better tested up there. So let's go ahead and cut it out from here and paste that there. Okay, so this is testing that, yeah, it created the data and the title and the data is correct. Okay, so the final one that we want to test is the list schema. Now, this one is a little bit different and maybe a little bit more challenging to test, but not by much. So we're going to go ahead and do from typing, we're going to import the list class. And so this is going to test that we actually have a list. And then we also want to import from Pydantic. We're going to go ahead and from Pydantic, we're going to import the parse obj as. Okay. So to test the entry schema or the list schemas, what we're going to do here is we're going to define test entries schema. And we'll give items here. Okay, so the items are going to be related to what we've had before. I'm going to go ahead and use an actual item here. And this should be content and again. And then let's go ahead and create another title with another content. And we'll say ABC. Okay, so what we want to do here now is obj list equals to parse obj as, and this is going to be our list, and it's going to be schema dot, and this is the entry list schema, and then we'll pass in items. Okay, so it's really just checking that value type, putting these items into it, and this will give us our object list. And in here, we should check a number of things, but let's just test it as is and see if it works. And we get this validation error. 2 validation errors for this list, right? So it's checking all of these items against what should be a list of these entry list schemas. All right, this is just a quick way to do it. We could loop through each one and initialize them very similar to what we did with the single item, but this is a quick way to just do it for all of them. Okay, so as we see that the ID is missing, right? So yet another validation error. So we can change this to entry list schema invalid IDs, right? So again, this field is required. It's not showing them. So yet again, we will use this with raises here. And I can really just put that one in, run that again. And sure enough, it's invalid. Okay, great. So now let's go ahead and actually add in the IDs themselves with basically the same thing. And this time it's going to be ID of 1. And let's make sure there's a colon here. And then an ID of 2. And no longer will it raise anything. It should just be like that. And we shouldn't see any errors come through. Now, these same things, it would probably be well worth to test the entry list class, the actual schema class itself, to test it against a lot of the same things we just did, including that ID, right? And so what we actually should have in here, though, is the final item. One single item should, well, it should actually have, I think, 5 keys. Now, the reason it should have 5 keys is this, and this. Okay, so let's just test that single thing. And I'll say first obj list item, or let's just call it first obj equals to that obj list and the 0th element. And then I'll go ahead and assert that the first obj dict.keys, let's say the length of it is equal to 5. Okay, let's give it a shot. And sure enough, it works. If I change this to 6, fails. Okay, and we can also see what is actually coming back with all of this data, right? So you could print it out in theory, but there's all that data there. But again, we'll leave it in as 5. Okay, great. So that is it for these automated tests. Now that we have that done, there's a couple things that we can consider doing with our data. One of them being related to Git. So if I do Git status, I should see all these changes. And if we actually went into the local repository and we did a run of PyTest. So in theory, when we actually do a push, we should probably run PyTest to make sure that it is validating everything prior to actually pushing. That's not something we're going to cover at this time, but you should know that it can be done. And it's actually fairly easy to do now that we understand how to actually create some of our own tests. But since we have this, we'll do git status and we'll do git add -- all, git commit, and added schema testing, or adding schema and testing, and then git push all. Okay, there we go.